this classes Clapyron equation can be derived from the third Maxwell equation. So dou P by dou T is equal to the dou S by dou V. It can be represented as equation 1. So equation 1 can be rewritten as dP by dt is equal to delta S by delta V, where delta S is equal to delta H by T and delta V is equal to RT by P if it obeys the ideal gas conditions. Substitute delta S and delta V values in equation 2, we will get equation 3. dP by P is equal to delta H by R to dt by T squared. So upon the integration, just apply the integration on the both sides, we can get the final Clapyron equation. Integration of dP by P is equal to delta H by R, integration of dt by T square. Then dP by P can be written as log P. Apply the upper limit and lower limit. In the same way, delta H by R is constant here. Minus 1 by T is the integration product of the dt by T square, because from the mathematics there is a integration of dx by x can be represented as log x, integration of dx by x square can be written as minus 1 by x. Apply those integration products to here for equation 3, we will get log P is the integration product of dP by P, delta H by R is constant, and minus 1 by T is the integration product of dt by T square. Okay. So by applying upper limit and lower limit, we can get the final equation. Log P2 by P1 is equal to delta H by R 1 by T1 minus 1 by T2, where P1, P2 are the vapor pressures of pure fluids at a temperature T1 and T2. Delta H is called heat of vaporization. It can be measured in terms of joule per mole Kelvin or kilojoule per mole Kelvin, where R represents the gas constant 8.314 joules per mole and Kelvin. So this equation is popularly used in the weather forecast and rain forecast, and it's also used in the estimation of temperatures at mountain places by knowing the vapor pressures. Okay. Let's apply the Clapyron equation for this tutorial A. So the barometric pressure at summit of Mount Everest is around 35 kilopascals. At what temperature would water boil at this pressure? Use the following information on the Earth's surface. Delta H is equal to 40.66 kilojoules per mole. R value is given 8.314 joule per mole Kelvin. T1 is 300 Kelvin, T1 is 101.3 kilopascals. This is the given. So let's check this Clapyron equation. Log of P2 by P1 is equal to delta H by R into 1 by T1 minus 1 by T2. T1, T2 are the temperatures in kelvins. T1, T2 are given kilopascals. Delta H is given heat of vaporization in terms of kilojoules per Kelvin and kilojoules per mole. That will be converted into joules. Just write down the given data. T1 300, T1 101.3 kilopascals, T2 is given 35 kilopascals, T2 to be estimated. Delta H value is converted into joules per mole Kelvin. R value is gas constant 8.314 joules per mole Kelvin. Just substitute all the values in the given Clapyron equation and determine the T2 value. So T2 is the temperature where water boils at the Mount Everest. Okay. Let's substitute the values. Log P2 35 kilopascals by P1 101.3 is equal to delta H 40.66 into 10 cube divided by 8.314 into 1 by T1 300 minus 1 by T2. Then substitute these values and you will get a T2 because approximately 70 degrees centigrade. You will get a T2 approximately 70 degrees centigrade.